Hello everyone. I, on behalf of State Council of Science, Technology and Environment, I would like to welcome the online viewers on this online class, especially my dear class 10 students. Today, I will deliver a talk on the physics portion of class 10 science, MBOSE, and I will be talking about electricity, that is chapter 3. So we are beginning with the chapter of electricity. In this chapter, we will be learning these concepts, these topics we will be learning. We will be learning about electric charge, its concept and its properties. The electric current, again its concepts and certain important topics that we need. Then we will be learning about electric potential and potential difference. The Ohm's law. Now the Ohm's law is a very important topic from the exam point of view as well as the concept point of view. It is an important topic in this chapter. We will be learning about resistance and resistivity, about electric current, about heating effect of current, and also about electric power. Now before actually coming into these topics, it is important for us to understand why do we need this chapter or why this chapter is included in our syllabus. Now as we look in our day-to-day life, as we look around in our surroundings, our life is full of applications or appliances of electricity. Our life would be very difficult, if we don't have this very important concept of electricity. If we do not have a current in our home, we can imagine our lives to be very difficult. Right from small things like using mobile to big things like starting a vehicle requires certain applications of electricity. So it is important, this makes this chapter very important for us to study. And moreover, electricity is a very important phenomena. It is important in what sense? Because this energy can be converted into different forms of energy. We can convert electrical energy into chemical energy. We can convert electric energy into mechanical energy, into heat energy. So that's why this syllabus, this chapter is included in our syllabus. So hence, we will learn about this chapter. We will go into details in these topics that I have written in here. And in doing so, I will be telling certain important points which are important from the exam point of view. Okay, so just a request for all the students, as we go through the topic, I want you to put the book in front of you so that I can refer certain points from the book. Now, the first and the most important concept that we need to learn in this chapter is electric charge. Without this, if we cannot understand this concept, the concept of electricity becomes a bit difficult. So what is this electric charge? We all know about it, but then it's very difficult to find a definition for it. So basically, electric charge is nothing but a basic entity of matter. In a proper definition can be given in this way. An electric charge is a property of matter which, due to which if I bring this matter in front or near to another object, this object will experience some force. Let's try to understand it with an example. This experiment, most of us have done this in our early lives. We take a scale, we rub it in our head, and then when we bring this scale to small pieces of paper, what happens to the pieces of paper? It gets attracted to the scale. Why is this happening? This is happening because of the fact that some charges are being induced in the scale. So this is charge. Charge is something that will make a material experience some force when it is brought to some other material. Now the SI unit of charge is coulomb, which is denoted by C. This is very important. An objective type of question may come asking you what is the SI unit of charge. So it is coulomb denoted by capital C. There are two types of charges. We have the positive charge and a negative charge. What is positive charge? According to the definition given in the book, it is an object where there is a deficiency of electrons. What it means that there is certain less amount of electrons compared to protons in this substance. Let us look at this using an example. In here I have taken the example of sodium. We have all learned in chemistry about sodium. The atomic number of sodium in here is 11. What it means the atomic number is 11? It means that the number of electrons and protons present in a sodium atom is 11. Now because of this fact that there are 11 protons and 11 electrons, the sodium atom will be neutral. Now to acquire a stable state, what happens? This sodium atom will lose one electron. It will lose one electron to acquire a stable state. Now when this happens, what happens in here is something like this. I have 11 electrons in the shell, in the outer shell, and 11 protons initially in the neutron, in the nucleus. Now when it loses one electron in here, the number of electrons in this particular ion is 10, whereas the number of protons is 11. So 10 protons and 10 electrons and 10 protons will cancel each other out, but there is one extra proton in here, due to which this sodium ion will acquire a positive charge. So as you can see, there is a deficiency of electron. This electron is moving out of this atom, so there is one less electron in here and one more proton. So because of this one less electron, this acquires a positive charge. So what is a positive charge? It is an object which have a deficiency of electrons. What about a negative charge? A negative charge, what is said to acquire a negative charge when there is an excess of electrons? But it means, again, let us look at this example. I have taken the example of chlorine. The atomic number of whose is 17. Atomic number is 17, that means there are 17 protons and 17 electrons. Now due to the fact that there are 17 protons and 17 electrons, that is equal number of protons and electrons, it is neutral. They are cancelling each other out. But in order to acquire a stable state, this chlorine atom will take in an electron from outside. That means it is taking an electron from outside. When it does so, there is an extra electron in here. Now because of this extra electron in here, the number of electron in here becomes now 18. So again, what is happening? 17 protons and 17 electrons are cancelling each other out, but there is one extra electron, due to which this particular ion becomes negatively charged. So chlorine is negatively charged. So what is negative charge? A body is said to acquire negative charge if there is an efficiency or if there is an excess of electrons. So it is important to understand the topic of charge. Why? Because we will need this topic throughout the chapter. Again, an important definition from the exam point of view. It is there in the book, you can go through the book. The definition of 1 coulomb. What is the definition? As I told you, the SI unit of charge is coulomb. What is the definition of 1 coulomb? A body is said to have 1 coulomb of charge. It may be negative charge or positive charge if there is 6.25 into 10 to the power 18 excess electrons or 6.25 into 10 to the power 18 less electrons in it. What I mean in here is something like this. Suppose I have a block of material. I have a block of material. In this block of material, suppose I have 7 into 10 to the power 18 electrons and 7 into 10 to the power 18 protons. As you can see, the number of electrons and the number of protons are same. So this is electrically neutral. There are no charge in it. Now suppose I bring in from outside 6.25 into 10 to the power 18 electrons. From what I am doing, I am bringing this many electrons from outside. Now when I do so, if you look in here, there is an excess of 6.25 into 10 to the power 18 coulomb. So in here, this body will acquire 1 coulomb of negative charge. So why it is 1 coulomb of negative charge? Because it is an excess of 6.25 into 10 to the power 18 coulombs. Again, suppose in this case, in the next case, what I am doing, instead of bringing this 6.25 into 10 to the power 18 coulombs from outside, I am actually taking 6.25 coulombs from here. I am taking 6.25 coulombs from here. So what happens now? When I do so, there are 6.25 plus 6.25 into 10 to the power 18 coulombs less in, electrons less in here. That means there are only 0.25, 0.75 into 10 to the power 18 electrons in here. If you see in here, the number of electrons is less than the number of protons. So in this case, I say that this particular body will acquire a charge of positive 1 coulomb, or I can say that this body has a positive 1 coulomb charge in here. So these definitions are important. Again, another topic or another point which we need to know is the properties of charge. The first and the most important property of charge is that like charges repels each other. Like charges repels each other. What I mean is that if I have a positive charged body, a positively charged body and a positively charged body, these two bodies will repel each other out. What it means, these two bodies will try to move away from each other. If I have a negative charge and a negative charge, these two bodies will try to again repel each other. They will try to move far from each other. But if I have two charges which are opposite, I have a positive charge, I have a negative charge, these two charges will attract each other. Again, another property of charge is that charge cannot be created, neither it can be destroyed. I cannot create charge, I cannot destroy charge. So these two properties are important. It may be asked in your exams. Okay, apart from the types of charges that we discussed earlier, there are two other charges which we need to discuss. The first type of charge is your static charge. What are these charges? These charges are present in your body, it resides in the body, but these charges cannot move from one part of the body to another. So, the electricity acquired by a body due to these type of charges is your static electricity. And there are charges which can freely move from one part of a body to another part of a body. So the electricity acquired by a body by these type of charges, the charges which can move from one part to another part, this is known as a current electricity. Now an example of static electricity can be the example that we discussed, the electricity acquired by your scale. Now these charges are there in the scale, but these charges cannot move from one part of the scale to the other. And your current electricity is the like the applications that we use in our day-to-day life. Now another topic is flow of charges. Okay, before coming into this, let us just take an example. A very simple example we can do, an experiment that we can do. Now suppose I have a hot cup of water or anything, a hot cup of tea maybe. Now when I leave this hot cup of tea in a table, what happens? After some time, after 10-20 minutes, this cup of water or this cup of tea, it becomes cold. Why? Because there is a transfer of heat from the cup of tea to the surrounding. And why is this happening? Because there is some temperature difference between the two media, between this cup of tea or water and the surrounding. Similarly in here, suppose I have two bodies. I have a body A and a body B. My body A is positively charged and my body B is negatively charged. As long as they are well separated from each other, nothing will happen. But suppose I bring these two charges near to each other and somehow I am connecting them. Now by experiments it has been seen that charges will flow from one body to another body. And why is this happening? Because there is a difference. This is positively charged and this is negatively charged. We'll talk about this difference in details later on. Now a question arises in here. Okay, charges are moving from one body to another body, but the question is, from where is it moving? Is it moving from A to B or from B to A? At that time, at that period of time, there was a big confusion regarding this. And to make things simpler, it was assumed, I repeat, it was assumed that charges flow from body A to body B. That is, charges flow from the positive body to the negative body, and this body A was said to be at a higher potential. The body A is considered to be at higher potential. I am repeating, this was just assumed, there was no proper experiment done, and the body B was considered to be at lower potential. So the scientists assumed that charges will flow from the higher potential, that is from the positive body, towards the lower potential, that is the negative body. And why is this happening? Because there is a difference between these two potentials. But later on, after the discovery of structure of atom, it was discovered that protons cannot move out of the nucleus. It is not very easy for a proton to come out of the nucleus. So hence this assumption was wrong. It was proved to be wrong. Actually what is happening, electrons or the negative charges are actually traveling from B to A. So this direction is the actual direction of charges and this direction is just an assumption. But we stick to our conventional flow of charges. That is, by convention we believe that charges are flowing from the positive terminal to the negative terminal. But you should remember that this is not true. The actual flow of charges is from the negative terminal towards the positive terminal. Again in here I get two types of current or two types of electricity. One is your conventional current and the other is your electronic current. What is conventional current? The current that we assume is flowing through a body from the positive terminal to the negative terminal by convention, that is by assumption. And what is electronic current? The actual flow of current, the actual flow of electrons from the negative body to the positive body. So again, this is important. It may come as your objective type of question asking you the difference between conventional and electronic current. Okay, next we'll be discussing about conductors and insulators. Now we all have a basic idea what a conductor and what an insulator is. So what is a conductor? Conductor is some body, it is a material which allows electric current to flow through it. And what is an insulator? It is an object or a body which does not allow electric current to flow through it. That is what we know till now, and for the time being we'll keep to that. Later on we'll discuss in detail about conductors and insulators as to why conductors are allowing electric current to flow through it, why is insulator not allowing. That we'll discuss later on. Again, earlier I discussed about your current electricity and static electricity, and also we discuss about your conventional current and electronic current. Now in this chapter we'll stick to the conventional current. The electronic current will be we'll study later on, but in this chapter we'll be focusing mainly in your conventional current. Now an important definition is what is an electric current? What do you understand by electric current? Electric current, it is nothing but the rate of flow of charges through a conductor. The rate of flow of charges through a conductor. The definition is simple, but we need to understand what it means. Suppose I have a conductor. This is a conductor and electric current is flowing through it. What is electric current? It is the amount of charge that will flow through this conductor. We have already discussed what a charge is. It is the amount of current flowing through this conductor in 1 second. That means the charge that will flow in this conductor in 1 second. That is your electric current. Mathematically, if I denote electric current by I, if I denote electric charge by Q, and if I denote time, the time taken for the charge to flow by T, mathematically it is given by this formula. I is equal to Q by T, and this is an important formula. We need this for numerical problems, and also many other things are, I can do many other problems using this formula. The SI unit of current is ampere. It is named after in honor of a famous scientist, Sir James Henry Mary Ampere. Again, this is an important definition from your exam point of view. What is the definition of 1 ohm? Not difficult. What we do, from this formula itself we are getting the definition of 1 ohm. In here, in this formula what I have I is equal to Q by T. What I do, I replace Q and T by 1. See what I want 1 ohm, and when will this current be 1? If I have 1 in here and if I have 1 in here. So basically what I am doing, instead of Q, I am putting 1 charge. That means the charge flowing is 1 coulomb. And the time taken for this charge to flow is 1 second. When I do this, I get my I is equal to 1 coulomb by 1 second. So I have 1 coulomb per second, or I have 1 ampere. So what is 1 ampere? What is 1 ampere? 1 ampere, it is the amount of current flowing through an object when 1 coulomb of charge flows through the object in time 1 second. So the definition is simple, just replace your charge by 1 coulomb and your time by your time by 1 second. So again I am repeating, what is 1 ampere? It is the amount of current flowing through a conductor, or I can say it is the current flowing through a conductor when 1 coulomb of charge flows through the conductor in a time of 1 second. So keep in mind this definition is important. Again I have other units of current other than ampere. What else I have? I have 1 milliampere. I can write this as 1 mA. So this will be 1 by 1000 A, or this I can also write this as 10 to the power minus 3 ampere. I have 1 microampere. I denote this by 1. This is the symbol used for micro, mu A. This is 1 by 10 to the power 6 ampere. So I have 10 to the power minus 6 ampere. These are the smaller units of ampere. I have bigger units of ampere like your mega ampere. First you have your kilo ampere. So I have 1 kA. This will be 1000 ampere, or I can also write this as 10 to the power 3 A. I have mega ampere. This is 1 MA. This is 10 to the power 6 ampere. So again keep these units in mind. It may be asked, like the question may come as an objective type. Okay. So having done about electric current, knowing the SI unit of current which is ampere, another question comes in our mind. How do we detect electric current, or how do we measure electric current? Now a simple way of measuring electric current is by using a device which is known as your ammeter. What is an ammeter? Ammeter is a device which is used to measure or detect electric current. And this this device is always connected in a circuit in series. Now series connection, parallel connection we have not done yet, but we'll do later on. But let's just keep this in mind. What is ammeter? It is a device which is used to detect or measure electric current, and this device is always connected in series in a circuit. So keeping these things in mind, we are done with electric current for the time being. Again we may discuss later on. Okay. Now an important question that arises in our mind is why conductors conduct electricity, and why do insulators does not allow electric current to flow through it. Now from chemistry we know that mostly metals are good conductors, or metals are conductors, and also we discussed about the atomic structure of a metal, that is sodium. Now in that structure, if you see, I have a free electron which can move out from the shell. Now always remember this, that if I have a block of metal, this metal will contain free electrons. And why this free electrons is coming? Because electrons are the valence electrons, or the electrons in the valence shell are loosely held. There is a very small force of attraction between the protons which are in the nucleus and the electrons which are in the valence shell, and this is true for your metal. Now because of this small force, or this weak force, this valence shell can easily move out from the atom, and they are free to move in the conductor. Now when I have a conductor and when I connect this to a source of electric current, what happens? What is electric current? These are nothing but flow of electrons. These are flow of charges. So what happens when I connect a conductor with a source of electric current? These electrons from the source of electric current will repel the electrons that are present initially in the in the conductor, and because of this the electrons present in the conductor will move freely inside the conductor. So it is because of these free electrons which can move easily through the conductor that conductor conducts electric current. Whereas if you look at insulators, that is non-metals, mostly non-metals, we can see that in non-metals electrons are not very loosely bound to the nucleus. That means there is a strong force of attraction between the positive charges, that is your protons in the nucleus and the electrons in the valence shell. So because of this strong force of attraction, the electrons in the valence shell, they are not free to move out from the atom. And when this happens, and because of this there are no free electrons in the insulator, and if there is no free electrons in the insulator, there is no electrons to be repelled by the electrons in the source. So because of this, your insulator does not allow electric current to flow through it. So here we conclude with the concept of electric current, and we'll stop here today. In the next class we'll be discussing about electric potential and potential difference.